So, scientific notation. How many of you guys have heard of this before? You guys remember what it is?
Oh. It just makes numbers smaller that are super big.
Yeah, it makes numbers that are super big smaller. So it's a process. We're going to have to use it a lot because we will be doing a lot of really big numbers and really small numbers as well. So the mass of an electron, this is chemistry, so we're going to deal with protons, neutrons, electrons, atoms, things like that, is 0.00000000000, a lot of zeros, 910,939 kilograms. That's how heavy it is. It's really, 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 really small. Now, let's say you wanted to know the mass of 550 electrons. Well, it's an easy math problem. Times it by 550. How many of you guys want to put that into a calculator? And expect that you're going to actually, it's going to take a while. How many zeros is that? Counting them out. What if you mess up when you're counting, right? So, scientific notation is a little easier to deal with in this case. So this exact same number written in scientific notation is 9.10939 times 10 to the negative 31 kilograms. It's a math problem. It's a little math problem that follows the same format, which when you punch this math problem into a calculator, you would do it, you actually get that number. So it's trying to shorten this big number down, make it a little more accurate, a little easier to work with. Okay? That's scientific notation. So let's do a couple of examples here. First one. 1,392,000. Okay, in scientific notation. First off, I want the number part of it, like the part of it that's actually got numbers to it. So I'm just going to really quick write those. 1, 3, 9, 2. I want to keep those so I know what number it is. Now I have to add a decimal. Okay? I want to add the decimal to this so that it is a small number between 1 and 10. Alright, so I'm going to put it right here. That's between 1 and 10, right? 1.392. Okay? And then my math problem is always times 10. And it's 10 raised to the power of something. Since this is a large number, it's going to be a positive power. Large numbers are positive powers, like big numbers are positive powers. And the number that it's going to be, that goes to the power of, is how many places I actually have to move the decimal. So normally the decimal's here at the end. Okay? And basically now I'm putting it here. So that is 6 spots over. So it's to the power of 6. The exponent's how many spots you're moving the decimal here. Normally it's over here at the end. It's not really written. But now I'm going to put it right over here, like I wrote right there. Okay? That's a big number. Let's do a small number next. So 0.000000028. Same process. Keep the numbers, 28. I want a number between 1 and 10 though, so I'm going to drop a decimal point right there. 2.8 between 1 and 10. Times 10. This time to the power. Since this is a small number, it's going to be a negative exponent. So negative. How many spots did I move the decimal place? 8. So I moved it 8 spots, so power of 8. Starts there. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Quick note. These exponents, are they how many zeros I'm knocking off? No. I only knocked off 3. So it's 6. This is how many spots you're moving that decimal place over. Okay? That's what that is. Now, this math problem, punch it into a calculator, you're going to get that number. This math problem, punch it into a calculator, you're going to get that number. So it's just a way of dealing with them by having a short math problem instead of the giant number. All right? Everybody try the other 3 on your sheet. I want you to try those other 3 yourselves. Okay, here are the answers to those 3. 1.0503 times 10 to the power of 11. The first one. The next one, 5.230. That 0, we do want to write it. I'll explain more about that tomorrow when we talk about significant figures. Times 10 to the negative 5. How many of you guys actually wrote that 0? Okay, I mean, it's okay if you didn't, but if you didn't, go ahead and write that really quick. I'll explain what the rule that goes for that one tomorrow. But times 10 to the negative 5. And then the last one, 4.08 times 10 to the power of 25. Yes?
I forgot what you said when you know if it's positive or negative. Tiny, isn't it?
Yeah, so large numbers, positive exponent. Small numbers like less than 1. Less than 1. Yeah, so things that are like 0.000 blah blah blah.
Okay.
Those are negatives.
Like some
Okay?
way past.
So trying going backwards. Okay, if we have 2.25 times 10 to the power of 5, basically do the math problem where you can just kind of move the decimal 5 spots. So 2, 2, 5. I moved it 2 spots there. You guys see that? 2, 2, 5. So far I moved it 2 spots. I need 3 more, right, to get 5 more spots? 5 spots? So I'm going to have to have zeros. 1, 2, 3. So that's 5 spots over. I'm adding the zeros there once I run out of numbers. Okay, it's large, so big number, positive exponent. Next one's a small number because it's got a negative exponent. So I'm going to move the decimal place 8 spots over this time. Okay? So here's my decimal where it's going to end up. I need 8. How many zeros is that going to be then? So I'm going to move it once over this way, and then I'm going to add zeros for the rest, right? So 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then there's the 3 for the 8. 7, 0. Okay? Question?